the AllThingsXR podcast. Where you can get the best AR/VR analyzers from the biggest names in the field. Hi everyone, welcome to the AllThingsXR podcast. I'm Dabble. In today's episode, we have a conversation with Neil Mathew, CEO of Placenote. Hi Neil.
Hey, how's it going, Dabble?
Thanks very much. Welcome to the AllThingsXR podcast. Can you tell us more about yourself and what you do?
So I'm Neil. Thanks for introducing me. I'm the CEO of Placenote. We started Placenote in about 2018, but we had started working in sort of the location-based AR space in 2017, about a few months actually before ARKit was launched. So since then, we've been building specifically technologies and products that change the way people interact with the world around them. And that's essentially our mission at Placenote, is to build tech, whether that's augmented reality, 3D scanning, and the whole spectrum of spatial tech that actually is specifically designed to change the way people interact with physical spaces, either in commercial or recreational ways. So that's what Placenote is really all about.
Great. So Neil, what is your background and how did you end up in AR?
Yeah, so actually my background is in robotics. I went to the University of Waterloo, which is in Canada, and I'm actually still based in Toronto. So I did my undergrad in mechatronics engineering, which is basically a fancy word for robotics, a combination of mostly software, electrical, mechanical. And after that, I actually did a master's in robotics as well, specifically focused on drones, so specifically focused on autonomous navigation. So things like 3D mapping, navigation on small edge computing devices. And through my master's, I met my co-founders, who were also my lab mates, and we were all working on pretty interesting projects, specifically around getting multiple drones to collaborate and navigate through tiny spaces and everything that goes with it. And through the course of that work, we got really interested in the possibilities of computer vision and 3D especially. Because it seemed like 3D was the obvious way for any computer or really any robot to navigate space, because it's the way we humans see things. And when these, we always, and as we were building these things, especially we were working on driverless cars and autonomous drones, edge computing on mobile devices hadn't really caught up to that point, but we'd always wonder, I wonder what could happen, what we could do with this tech if it was possible in phones. You could do things like get, people with vision impairments to walk and not collide into things. You could build technologies that let people scan their homes and design their spaces with furniture. And it was always this thing at the back of our minds. And so when that happened on mobile, and when we finally started seeing this kind of tech actually becoming a reality on mobile, we decided that we had to jump onto it. So that's really kind of the story of Placenote.
Great. Can you tell us more about the Placenote SDK? And I think it was your main product from the beginning, right?
Yeah, so Placenote SDK. So when we first started Placenote, the AR industry is always evolving, and I think everyone in this space is sort of still, finding their way, right? Including, the startups include as well as the FAANG companies,
exactly,
as well as the large companies, and so it's always, it has been a long road of experimentation, as everyone has seen.
Yeah.
And so at the beginning, our thought was, we were inspired by something, a really interesting event. All of us, we were sort of really interested in travel, and we really enjoyed booking and staying at Airbnbs. And one of the things that was always annoying to me when I moved into a new Airbnb was the whole check-in process. Trying to figure out where everything is, trying to understand like how to get in, which key to unlock, because every Airbnb host had a different setup, and they didn't have the standard check-in process like they do now. And so, a couple of Airbnbs that I went to had done something interesting. The host had actually put post-it notes in a bunch of different places around the Airbnb explaining how to do certain things. Like on the door, they put a post-it note that said, hey, like there's a lock on top, but don't turn that, turn this one because you lock yourself in, or here's the thermostat. And I thought that was so interesting because, a post-it note is such a simple little thing. But it's so valuable because it puts knowledge in the context when you need it and where you need it.
Exactly.
Right? And we kept whinking about that. Like, why is the Post-it note so great? And it's that it really offloads your mind to think about the broad scope of things, while the little details are instantly fed to you when you need it.
Mm-hmm.
No information overload. And that's one of the problems in our in the current way of doing things, right? As we use computers and phones with these like 2D screens, information overload is something that everyone deals with. And so we thought, one of the great things about natural interfaces or interfaces in augmented reality or virtual reality is that they can be really contextual and really natural. And, my goal has always been, if I can build something that my mom can use, then I think I have a win.
Yeah, exactly.
And so that's where the simple idea of placing a note on something started off this thought process that actually led to Placenote. And so the first kind of prototype that we built was literally an app that you could take and place these virtual sticky notes on different things.
Mm-hmm.
And it had its challenges. Like when ARKit first came out, it was definitely not as stable as it is now.
Yeah.
So if you play, and actually ARKit did not have any word mapping capability. And so we wanted to actually build something that you could scan an area, or not even scan an area, just place these notes all around a room, whether that's in your home or at a workplace. Let's say there's a printer at work and you want to tell people how to use it. If you could put the instructions for using the printer in like little simple sticky notes all over the printer, that could make it a really easy way to discuss or communicate information about physical space that you might usually have had to just take a bunch of photos or videos and write notes about. So we started with that really simple demo, and as we were building that, we realized the hardest thing to do was to build a really stable world mapping platform.
Mm-hmm.
And it wasn't just the fact that localization and accurate localization was the issue. It was also, if you take that thought process further, you realize, well, okay, you can localize on a printer. What happens if you have to do this in a room, or what happens if you have to do this in a conference center or an entire building?
Yeah.
What do you build, or what do you actually need? What needs to happen before you can create world scale or even building scale AR experiences? And so, we started off with this idea of placing notes, and doing that, we realized that the technology stack that was needed to be built to actually get these sorts of AR experiences or location-based AR experiences to exist did exist. And we didn't think that the larger platform players would be in a position to build that because, number one, privacy is a big deal.
Yeah.
Number two, for a platform player like Apple, who I think is, really in the best place to build most of these things.
Yeah.
But, if you think about Apple, a platform player like Apple, they're specifically interested in selling more iPhones. And so given that as a goal, or selling more devices, given that as a goal, it doesn't really make sense for Apple to try and build a sort of third-party cross-platform localization service, which ultimately, at some point, for there to be able to be these sort of world-scale AR experiences, you really do need a cross-platform solution. And we thought that a third-party product would really be the one to build this. And so that's how we decided to kind of start Placenote. And at the beginning, it was with AR. It's always the biggest risk I think in this industry that most people face, given that we're all technologists, we're all engineers, is we try to build solutions before the problems exist.
Yeah.
And that has been a curse of this industry, I think.
Exactly.
And but it's normal, at any one point. So we went through Y-Combinator, and we were really lucky early on to meet Paul Graham. And one of the things he said was, in the early days of computers, no one really knew what you could do with it. People were just trying to build cool stuff, and eventually the use cases sort of started to materialize. And your goal as a company should just be to survive until that happens. And they have this really interesting analogy where, some companies are unicorns where you get a lot of publicity, you raise a lot of money, and then you're a rocket ship and you have to burn a lot to actually get to the point and you hope that you become a viable business before. But in an industry like AR, which is so nascent and so new and so gradually, unfurling and revealing itself, the analogy is that you should be a cockroach, so that even if there's a nuclear Armageddon, you'll still survive. and we really took that to heart. We were trying to figure out, okay, so given that, let's try to figure out how we can become a viable business, even given the fact that the technology is not perfect and the use cases haven't really quite become clear yet. And so we thought Placenote would be sort of a way for us to put a foot into the door, to get initial developers who were trying to build AR games and AR experiences to try and experiment with the concept of world scale AR, and all the applications that brings. And so that's how Placenote SDK launched. We brought on some really, really interesting developers who were building a whole bunch of applications, games. There were a lot of people building annotation apps. So, apps where you literally put digital sticky notes on things. And through that, we were actually able to do a few really interesting enterprise pilots with companies like Home Depot, American Family Insurance, Jacobs Inspection, and some really big vacation rental companies as well. And through that, we started really learning how different developers and companies are looking at the future of AR. What do people think location-based AR is? And actually, if you think about it, there is no good location-based AR. There has been no good location-based AR app since Pokemon Go, right?
Yeah.
You could argue whether Pokemon Go is truly an AR app or not. But there's been nothing. And the reason is the ecosystem was just never in place for the use cases to come up, right? There's just so many, like even if Placenote has built the perfect localization system today, there's still the issue of someone having to hold their phone up and then try and initialize the
Exactly.
and then start the app. And so it's definitely a long learning experience, but it's been a really interesting journey. And so that's where I'm sure we'll get to Dabble and things like that. But that was the origin of Placenote and sort of what we did in the early days.
Great. So, Neil, can we go a little bit more technical here? As you said, the main challenge for many AR apps and applications is localization for building a context-aware system. How did you solve this challenge, and what was your solution to this?
Yeah. So, we saw two approaches here. One was start small and go big. And the other was go big with low accuracy and then hone into higher accuracy in a smaller scale. And that's ultimately the challenge here. Either you have something like GPS, or even at a building scale, you have something like beacons, BLE beacons, that give you large scale localization, but at the accuracy of, let's say, 5 meters or so, which is, okay for some applications, it's okay for navigation, but not really okay for AR overlays. And then you have something small scale, like what we were building at Placenote, which was essentially going to be a localized mapping solution. So we figured, let's start with a very simple localized mapping solution where we would overlay ARKit with our own feature detector, which is sort of the approach a lot of the others in this space, like 6D, for example, was taking a similar approach, where what we would do is we would add our own feature detectors on top of ARKit. We would use the ARKit data that's being pumped out of ARKit, like the IMU and the position as our sort of dead reckoning in our entire kind of measurement model. And then build our own kind of lower frequency feature detector that would basically let you create a point cloud, a really sparse point cloud, not something that would let you create a 3D scan, but a point cloud that would just let the algorithm detect a specific area, like a scene recognition. And the way it would work is we had built a system. So it was a two-part system where the algorithms, the library on the phone would do the local mapping and localization, and we would automatically sync it with the cloud. So as a developer, you don't need to deal with, saving the map, uploading the map to the cloud, and then downloading it again every time you want to share a map on different devices that you have to do with something like the ARKit World Map.
Exactly.
What we would do is we would just auto sync everything. So the way it worked was a user starts session on their phone. As they're placing these notes or playing a game, the mapping happens in the background. And then when the mapping is done, we save the map, upload it to the cloud, and now that can be downloaded whenever needed. So we would, whenever that phone or another phone is in the area and they want to localize against that map, they would essentially sync to the right map ID that would be downloaded, and then you have the experience and you're contextualized in the experience. So that was kind of how it worked at the beginning. And our goal really with that, sort of workflow was that we would then evolve that to do things like, instead of, just using the cloud as a way to upload and download a single map, we would use it as a way to stream maps. So that way you could do things at a much larger scale. Alternatively, we could have also done a more tile-based approach. So in the way that Google Maps works, we could actually map an entire area and then only load the tiles that were necessary to localize in the area that you were in. And so that would be
interesting.
That, although that needs a hybrid approach. So you would take a larger scale, low accuracy localization with GPS and combine that with our mapping, so that when the area that you're in, you just load the 3D maps of that area and then localize within that. And so there's a number of different approaches, but ultimately, I think one of the other interesting things was with, I think this company is called Scape, but what they were doing, and another company is called Sturfy, and what they are doing is just large-scale city localization. So, but at a lower accuracy, right? So they would take features at the building scale, as opposed to point features that we were using, or they would take, someone like Sturfy, they were taking satellite maps and trying to localize against those. And so combining that with something that Placenote provided, and we had some conversations with a bunch of different companies about this, trying to combine those two approaches is really the ultimate solution. But it's definitely, it is a lot. It's a very big technical goal to do that.
Yeah, exactly. Neil, you also had a great tech for 3D scanning in real time. I think it was even before LiDARs in Apple devices. What is the usual process of R&D for such a project in your startup? Because it's not something you get out of the box from ARKit or another framework.
Yeah, so we had actually, when we started having conversations with enterprises, we were doing some enterprise pilots with actually companies like Airbnb, Home Depot, and things like that. And one of the things that had become clear was, we'd also had conversations with companies that were doing interior design. So companies like Modsy, Havenly, Hover. These companies have sort of identified a use case for 3D modeling of indoor spaces. Including things like Matterport, Zillow. These companies also need models of indoor spaces, and they've all figured out ways to do it in different ways. So, for example, Modsy, they have, they combine a little bit of photogrammetry with some manual inputs to try and generate CAD models of indoor spaces. Same goes with a bunch of different companies. Matterport has a really interesting tool that combines 360 cameras, phones, and their own custom 3D scanners. So when we started to work on Placenote, naturally the conversations about how people can interact with physical space go towards 3D models. Because if you think about it, if I am working in industrial inspection, I go up to a site and I'm inspecting the site and I place a bunch of notes in that area so that someone else can come and inspect the site. So now those notes are accessible to someone else who's on that site. But what if those notes need to be accessed outside of that site or off-site? So the idea then was, well, maybe we do a virtual tour and let people access them just in the way that Matterport does. But that doesn't give you a sense of, that doesn't let you measure, it doesn't give you a sense of 3D structure. So the natural next step was, okay, well, can we build a digital twin of any physical site, whether that's a home or a industrial site, and bring that into some interface that you can interact with, so that if you imagine there's a person off-site interacting with a 3D map, and the person on-site can actually view that happen in real time while they're there. So it's sort of this God mode or puppet mode. And that was kind of the initial thought process there. And we thought that was really interesting because even before we knew, I mean, no one knew whether LiDAR was going to happen on Apple phones or devices at all, because the previous experiment with LiDAR was Google Tango, right? And Google Tango was, it was an interesting approach and it actually worked really well, but unfortunately it wasn't a commercial success. And so there's a lot of challenges with building LiDAR, including the cost of the device, weight of the device. And, Apple now, it's clear that this is the future on Apple devices, but it wasn't then. And so for us to then, as we had these conversations, we knew that at some point, 3D scanning on mobile devices would be inevitable. Whether that's on LiDAR or cameras is out of the question, right? Because, I mean, this is the same conversation happening in self-driving cars. Tesla is all in on cameras, GM is all in on LiDAR. And we figured it was going to be the same thing. And so we figured regardless of whether LiDAR is released or not, camera-based 3D scanning is going to be important, because even with the LiDAR, you're going to need texturing from somewhere. And where is that coming? It's coming from the camera. And so we decided that we would actually incorporate, and actually I think 6D had a really interesting 3D scanning tool as well. And we weren't at Placenote. Our goal was never really to build an occlusion, an occlusion system, because my view on occlusion was, or my view on building an AR SDK as a business was, you should really build application. You should really build, if you're building a technology stack on top of a platform like Apple, you should enable brand new applications. And my view on occlusion was, it creates a better visual experience, but doesn't necessarily create a brand new experience. Because, you can play a game with or without occlusion, but you can't have a location-based AR app without location. So that's why we sort of went all in on the localization first on Placenote. But as a next step, what we wanted to do was we wanted to build a way to sort of let a person interact with the same physical space online and sort of on-site and off-site. So we decided to build 3D scanning. And we already had a background in monocular 3D scanning, which is basically 3D scanning using a single camera. And so, using standard approaches with structure from motion was how we started. But the hardest part is, you can take these standard approaches, but really optimizing it for your use case and optimizing it for mobile, because they're really never haven't been designed to work on mobile. That was the hardest part. But the problem is there's always challenges, right? So building a business around it is kind of interesting because there's always challenges. So for example, you can build a great scanning app, but it has limitations. It can't really scan white walls. It can't scan mirrors, because as soon as you point it at a mirror, you're now screwed up. So what do you do? And so that's been sort of a really interesting journey. We started off with building a system that could just create a map of a single room so that you could add it to Unity and then build physical sort of location-based experiences with it. We had a tool called Spatial Studio where you could basically scan a room, bring it into Unity, and then use Placenote localization as well as the 3D map to position things, to position static assets in this unit, in this 3D space. And then you load it back, and now you have your world set up, but it's fully location aware. And that was actually very popular with developers. So we had developers building, escape rooms and location-based haunted house experiences, location-based theater, because you need to know, because, I mean, here's the thing, even if you don't have live occlusion, which is hard, right? Because you need to detect things so perfectly and so crisply for occlusion to look real. But if you could map things in advance, you at least have occlusion against the larger structure. So behind a wall, things would get occluded. A person may not occlude it as much, which was actually a happy medium. So we started to build 3D scanning, and it's a really interesting kind of R&D process, because you have to find, I like to use the analogy of building a car. Right. So if you want to build a car as an engineer, the tendency is to first build the chassis, then build the engine, then build then build the interiors and the body.
Yeah.
But really, if you want to build a car business, first you should build a skateboard, then build a bike, and then build a motorcycle, and then build a car. Every step of the way, every milestone that you hit should be a saleable business. It should be an actual product that you can sell. And so that's been an interesting challenge, because none of this technology works 100% of the time. You have to figure out the really narrow use cases where you can make this work perfectly. And then within those use cases, try and build a really viable business, and gradually then expand out in concentric circles. And I think that's been the biggest, the biggest bottleneck or failure in the AR industry has been to try and identify narrow use cases where, regardless of the limitations of the technology, we can make a business work. And 3D scanning is the same. Like, even with LiDAR, you don't actually have perfect 3D scanning. So, which users do you target, right? Most 3D scanning apps out there right now, most LiDAR scanning apps out there right now are targeting fringe users, right? Which is actually the right way to do it, right? You want to target the early adopters first. But where do you go from there? How do you, turn that into a business? And there's some products that are targeting construction. There are some products that are targeting archaeologists. So there's a lot of different paths through it. And it's really interesting, I think, to find your way through it, because the technology is so exciting, and that, we're really excited to get it out there. I just want people to experience it. But then you got to be really strategic about how you find your way through the market.
Mm-hmm. So let's get to your latest project, Dabble. What is Dabble, and what is your vision for it?
Yeah, so Dabble, we see Dabble as a use case on top of Placenote SDK. Mm-hmm. And here's how we kind of structured it and what went through the decision. So, as we were working on Placenote, we were engaged in a number of pilot projects until the beginning of 2020, right around the pandemic. And right at the start of the pandemic, we began to notice that, a lot of the companies that we're doing R&D projects with had been struggling because of the pandemic, and around, I would say, June of last year. And so, the first thing that goes in tough financial situations is the R&D projects. And so we had a period where we were struggling with some of our R&D projects being canceled or delayed. And so we, at that point, kind of as a team, got together and decided that we had to make a decision about whether, at this point, we were so dependent on the enterprise pilots for us to kind of progress and our technology to progress. And at the same time, people weren't physically going to any location. And so the idea of building a location-based AR SDK seemed to be, a short-term thinking. And we didn't know when that would actually change. Like, when would the world go back to normal? And so we decided that, okay, Placenote is really there are two big pillars of Placenote. One is the location-based, sort of the localization piece, and the large-scale localization piece. And the second is the 3D scanning piece. And we said that, we decided to make a bet on 3D scanning, because 3D scanning would at least be a way to enable remote work. It would let people engage in physical spaces remotely, and that seemed like the logical next step. And we said, okay, let's look at 3D scanning and see what we can do with it. And at that time, I think iPad was the one iPad had a LiDAR on it.
Yeah.
But that was about it. And so we had actually been talking to a bunch of companies while obviously, we were talking to a lot of companies to try and figure out what that best path for 3D scanning could be. We had talked to Home Depot, Havenly, Shopify, Modsy, and one of the applications that kept coming up over and over again was this idea of spatial e-commerce, where, there have been apps that let you visualize furniture and home goods or any product really in your space. And there's also applications that will help people design, hire an interior designer where the company will kind of design a CAD model of your physical space. And so what we'd heard from each of these companies was, if there was a way to basically take a 3D model or a 3D scan of any indoor space, like let's say a home, and then not just stop at 3D scanning, but extract all the salient features of that space, like understand exactly what the floor plan is, understand where the windows are, the color of the walls, the floor, extract the furniture that's in there. So one of the pilot projects we've been working on was to scan a home and then figure out exactly what furniture is in there and create a floor plan that included the outline of the space as well as the layout of the furniture. As a starting point to design, as a starting point to interior design. And we thought that was really interesting because one of our goals has always been to build the perfect 3D perception system. If you could take your phone and wave it around a home and instantly get a floor plan as well as a list of all the furniture that you have. So you have a blue fabric couch with wooden legs, that level of detail, right? If you could get that, and then you could essentially take all the furniture that you have. Let's say you have 3 or 4 items of furniture, like a blue couch, a red rug, and a brown coffee table. And you could use machine learning to then recommend products that would look good and fit in your space. So it would fit in your space as a starting point.
That's great.
And look good. So if you have a blue couch and a red rug, what pillow cover should you get? Maybe you should get a blue pillow cover with a little bit of a red design. Right? People don't know these things. People want to find things that look good in their space, but they have a really hard time color coding and color matching and finding things that fit. And so there's really 2 ways to buy furniture, right? One is you go to Wayfair and you browse forever until you get tired. And the second is you hire an interior designer to design your space. But, most people don't want to hire an interior designer because number one, it's expensive. And number 2, the interior designers will always recommend expensive products because they make their commissions through that. So we realized that between the spectrum of 100% personalized interior design and 100% self-serve e-commerce, there had to be a middle ground that brings in that personalized experience, but also gives people a way to sort of DIY. And we saw a lot of e-commerce sort of headed in that direction, right? So, I would say there's a really good article by Greg Eisenberg of Late Checkout who says, he says in this article that, 20 years ago, e-commerce was novel just because it was electronic, right? The fact that you could go on the internet and buy something was great. And that hasn't really changed since then. If you look at what's happening with e-commerce in China, they have, things like live stream e-commerce, social e-commerce. They're really experimenting with new models of e-commerce. And North America has sort of been stuck in this sort of 2-dimensional grids of furniture browsing that you're browsing on your phone or your laptop, or Instagram and Pinterest that are reasonably good tools to discover products, but not really great in terms of trying to replace that in-person experience. So we figured that if we could take 3D scanning, the technology of 3D scanning, and wrap it, maybe it's a smaller use case, maybe it's a narrower scope, but if we could wrap it in a use case that was really valuable here and now, then that serves as the perfect starting point to the Placenote platform. So really our goal was, let's stop our enterprise pilots and let's focus in on let's go all in on a single product to say, hey, we're going to build the perfect spatial e-commerce experience and use that as the first use case of Placenote. Because think about what happens once you have a 3D model of your home, right? A 3D model of your home is a standard canvas on which a lot of applications can be built. So let's say a real estate agent creates the model of your home. That's used in the sale. Once you buy the home, you use the same 3D model to actually design your home. Once you design your home with it, now you have an inventory of everything you own, as well as a 3D model of your space. So God forbid there's some damage or flooding in your space, the same model can be used by an insurance company to try and verify your claim. The same model can then be used to redesign your space or renovate. So for example, you have a scan of your home. I recently got a stair renovation done. And the contractor had to send me lots of pictures of stair renovations in other places so I could visualize what my space could look like. Visualization of a stair renovation should be such a simple thing, but it's actually so hard because there's no way to bridge that gap between the work that is to be done and the current built environment. Like, just ask an architect. The amount of work that goes into rebuilding existing conditions, or what they call as-builts, is almost 25% of the whole project. So we realized that, if we want to make 3D scanning work, we have to find a use case for it that starts off with something everyone can relate to. And that's where Dabble started. And the funny thing is, we didn't start Dabble with a 3D scan. Our thought process has never been that we'll build really cool technology, get it out there, get some attention, because the end of the road for most cool tech is to be acquired, unless they can really build a viable business, right? And so our roadmap, or the roadmap that we, fortunately or unfortunately have chosen for ourselves, has been, we want to start off with a solid baseline business and then enhance it with the tech that we're really passionate about building. And so that's where kind of the Dabble roadmap really comes into play, is that we've started, when we started Dabble, we realized there are two problems to solve here. One is, if you're buying some furniture, you want to know if it looks good in your space and whether it fits in your space. Fit cannot be solved without a 3D scan. But if we make a 3D scanner and try to release it, people who are not really into the 3D world, your average person who lives in Midwest America, tries to scan their home, they're going to look at this warpy, mangled mess of a LiDAR scanner and be really confused, right?
Yeah.
How do you make that look perfect? So we figured, okay, let's decouple these. Let's attack the problem of style first. And let's try to build what we call now a Canva for interior design, which is basically like a 2D designer that lets you clip a product from anywhere online, pull it into a little mood board, and design your home. And then now we're going to add the ability to rotate and change the perspective on items, and eventually sort of make our way step by step towards a full 3D room designer that then plugs into other e-commerce companies and basically becomes a sort of perfect one-stop shop for furniture and interior design. And going beyond that, then we take the sort of, build the tool first and expand the platform after approach, where Placenote can then take everything that we built in Dabble and expand that 3D scanning to other use cases like insurance, like contracting, and things like that. And so that's how we see Dabble and Placenote sort of really working together.
Great. Thanks very much, Neil. So, as you said, all of these, from Placenote to 3D scanning to Dabble, are all related. But you have pivoted from idea to see how you can make them work. How you make these decisions, these pivoting decisions, and was it hard to pivot from the initial idea and go after something new?
It's definitely hard, because when you first start down a certain path, you don't necessarily know if it's going to work. And, although we all try to do as much research and try to, learn as much as possible about a market before we get started, it's just really hard to know everything. Hindsight is always 20/20, right? So when we, for example, started with Placenote SDK, we had made some assumptions about how the AR market was going to evolve, and and how the ecosystem of AR around Placenote SDK would evolve. And one of the things that we realized was, timing is such a big deal, right? Like, if you to get a product to grow at the rate you want it to, you need to make sure that you not just have product market fit, but you have timing fit. And so that's been part of the struggle, is that with Placenote, I think all the projects we were doing, they were met with a lot of enthusiasm among innovation teams at enterprises as well as developers, but everyone saw it as a very initial taste of what AR can do. And so, it felt like we were a little bit early in trying to push this out. And we didn't have a very clear path to sort of, we didn't really have a clear understanding of when we would be in production, or when this technology would be good enough. And it's really hard to know what is good enough, right? Like from a technical perspective, we see that where even ARKit was 2 years ago and where it is today, it's come such a long way. But if you look at the average consumer using an AR app, they still think it's not good enough. So it comes down to a question of perspective. And so for us, you can at some point, the way we've approached this is we are always questioning whether we've made the right decision, and if you keep questioning it too much, you get burnout and it's too exhausting and demotivating. But you have to try and find that balance between persevering down a certain route, and deciding that, okay, I think we need a change of plan. And the thing is, people, when you think about a pivot, it really comes down to what are you pivoting, right? There's different types of pivots. On one hand, you may be really focused on a specific kind of customer, but not sure exactly how to solve that problem, and pivot from one idea to another to figure out whether that problem is being solved for that customer. And on the other hand, you might have a specific vision, and you're really passionate about heading towards that vision, but you're not quite sure what the specific path to that vision is. I have this really interesting quote from Jon Stewart that you should have a clarity of vision and a flexibility of process. Right. And that's kind of the way I think about it, is that right now, what everyone in this industry is trying to do is find the right process. And process is something that is ever changing. And so, whether but it's certainly, regardless of all of that, it's hard, right? You have to convince your team, you have to convince your investors, you have to convince yourself that the next thing you do is an evolution or actually an improvement. And it's very easy to make emotional decisions, and it's very easy to make snap decisions when something's not working. But we've had to be really, really careful that any decision we make is being informed with actual data, and so we don't take that lightly. Even with Dabble, I mean, just switching from building Placenote SDK to focusing on a 2D furniture designer, it looks like a big change. But to us, it was, the way we were thinking about it was, if you want to build an autonomous car, build a taxi company first and then automate all of your cars. You'll build a much more stable and successful business. And so we thought, okay, we should be able to build a successful business without using 3D scanning as a crutch, because 3D scanning ultimately, the tech behind everything that we build in this industry is so cool that I think there's a tendency to use the technology as a crutch instead of because it's your technology is always your defensibility or your moat. It's not the first thing that's going to make or break your business. And so we've sort of tried hard to keep that in mind and try to make sure that our decisions are in line with the data. But it is. I'm not gonna lie. It's definitely a very hard thing to do. Both physically and emotionally.
yeah, I've experienced that. Neil, I think I myself can say that I'm an AR evangelist, as someone who's been in the field for the past 11 years. But from a business and founder standpoint, it is not something that we see great exits and lots of money and etc. When do you think the AR prime time for founders and activists in this field will come?
Yeah, I mean, it seems like right now all everyone can talk about is crypto and
exactly.
and so at some point I think one of my investors had sent me this graph, which is, it's kind of funny how investors kind of think about this space. And there was a graph. It was AI has made this like leap into successful businesses.
Yeah.
Crypto is just behind that, and then spatial is still further behind that. And I think, if you think about AI, right? AI, people were working on AI since the 50s and 60s.
Yeah.
But it's only been in the last 10 years that the real, true, applications and huge applications of AI have materialized. And so I think, there have been some early wins in the spatial industry, but there's still, no consumer, I think I would say most people I know have not experienced an AR or a VR app.
Mm-hmm. Yeah,
right?
you're right.
Still. So what is stopping that? And there's a combination of things. I think one of the things with AR and VR is you're not just, you remember the Google Glass rollout and the
that
the huge disaster. Exactly.
Yeah.
And same with Snap spectacles. They had some success, but nothing that you would really call a huge success. And the reason is there's several reasons, right? I think one is obviously at some point, like the technology ecosystem has to hit a inflection point. You have to have devices that look like regular glasses, that are able to stream data at a certain rate, that are able to actually visualize things at a high field of view. We can talk about all of these things, but the bigger thing is also the cultural issue. Like, why do we need glasses that look like regular glasses? Because people ultimately don't want to put a big thing on their face. And even going beyond that, I think one of the things that we've had to learn the hard way is so let's talk about for a second, let's talk about the digital sticky note. When we first thought about the idea of placing notes in physical spaces, it seemed like a no-brainer, amazing idea. And everyone that we talked to about the idea, online, on LinkedIn, or in physical, in meetups, it was an instant hit, because when you think about the idea and say, oh well, I could see information wherever I want it seems like a logical fit. But then if you start digging into, okay, so let's talk about the applications this is useful in. Let's talk about Airbnb check-ins. If someone's checking into an Airbnb, are they going to download an app for this one-time thing that they do? Probably not. So you're stuck right there. People are not going to download an app just for a single check-in. So even if it's integrated into Airbnb, the effort of lifting your phone up to your face and looking at something is enough of a friction point to make that less useful. Then we'll talk about industrial use cases. So we were trying to build a use case where if you were in a manufacturing plant or if you're in an inspection facility, you would place notes for the next person to come and verify. And when you think about that, it seems really great and logical up front. But then you think about, okay, the person walking in, and you think about how their day is going, and you think about their actual user journey, you realize that, okay, well, the first time they do this, maybe they want to know where something is. Now, if they want, the second time they use it, they know where everything is. They don't need this app. They need it once.
Yeah.
And even if they don't know where things are, can you tell me truly that viewing something as an AR note is better than just viewing a photo with a mark on it or a video with a mark on it? You can't, right? Because ultimately you have to you have to ask why and why and why so many times until you get to the root of it to figure out where is AR actually useful. I think, I don't know if you've talked to Scope AR, but the founder of Scope AR, Scott Montgomery. So one of the things, I read in an article about, I think they wrote a blog post about, going from hype to reality in AR. And one of the things he said is when they first started out, they were trying to build a HoloLens application for manufacturing facilities where they would show training instructions on the HoloLens, right? And again, that seems great. But in what applications does that actually make sense? And what they realize is, initially you do lots of pilot projects because there's a lot of hype around this. But ultimately you realize that you cannot work in applications where the volume of work is high. Like if you're doing repeated tasks, you don't need AR because your brain remembers where things are.
Yeah.
What you can only use AR is only useful. Especially this AR work instructions is really only useful if you're working in a very, very complex environment with a very complex task that you can't remember, and where the volume of work is small enough that you don't remember things from one thing to the next. And literally one of the only use cases that they were able to truly find product market fit in is designing rocket ships or designing some sort of complex equipment for Lockheed Martin, which is such a niche product to focus on. But that's the only place where that value that AR and the visual overlay provides actually makes sense. And so that's the hard part, is because this technology is so interesting and so exciting that you really have to think of it as just another UX to be able to fix, and then really dive into the true reasons that make this more useful than just a picture or video. And I think that's sort of what makes this really hard, is because even the companies that you're trying to sell to will buy into it and buy into the product initially because it's really cool. Right? Yeah. But then how do you then as a startup, not get excited by that and say, okay, well, these people are buying into it, and they'll pay big bucks, right? They'll pay like $500,000 or something. And as a startup, you're thinking, oh my God, I've made it, right? This is amazing. But the reality is that they're just paying you to learn about new tech. They're not even sure how they're going to productize this. And you have to be, as a startup, you as the product founder, you have to be the one to drive that. And I think, because that is such a hard thing to do, that's what makes this really hard to turn it into a viable business. And that's something we've learned as well, right? We did tons of pilots that seemed like they were going great initially, but then when it came time to convert to, a long-term paying product, that became, they were obviously paid pilots, so we thought we had really hit a hole in one. But at the end of the pilot, you have to sort of, you get, when it gets down to, okay, let's now figure out the exact use cases where we can now start using this, that's when this becomes a problem. And so it's definitely like a lot of interesting lessons learned that we're now using as stepping stones as we work on our own product.
Yeah, completely agree. So Neil, as of our last question, how do you see the future of AR?
Oh, okay, that's a good question. So I think one of the interesting things that we have been noticing is the sort of the emergence of 3D as a mode of interaction, even without AR and VR. So, for example, if you've played with Mozilla Hubs, Fortnite. People are actually hanging out in 3D environments already, and it started off as pure gaming, but it's now more than gaming, right? Fortnite is hosting concerts, and there are people who are buying into the NFT craze that are also experiencing more and more 3D. There's a lot more 3D artists that are getting a lot better and making a lot more money, and there's also there's also a lot of new tools to actually create 3D content. And so we had this conversation in our team at one point saying, what is that? And the main question was, what is the biggest bottleneck to AR and VR today? And I think it's actually 3D content creation. Because if you told me to paint a picture, I would do a 2D picture. I could take a photo and post it on Instagram. I could paint a picture with my iPad using an Apple Pencil. But if you told me to create a 3D model of some character, I would have to open up Blender, and that is a huge black hole. Creating 3D content is so hard. It's 100 times harder than doing anything else, any other kind of content. And that's the first thing that needs to change, because VR has now been around for a long time, and I would still not say that there's really great content in VR. There's some good content, but just it's not that great. And so one of the things that's been stopping AR and VR from growing really well is the lack of great content. And so I'm really excited now about 3D experiences that are outside of AR and VR, either just on mobile or just on desktop, that let people get an initial taste of what 3D is. Because even until today, panning and tilting, zooming in and out of a 3D model is still too hard for my mom. And based on my initial kind of metric of can my mom use this, it still fails. but but my younger brother has been playing games since he was since he was 4. So, this is a generational change, right? People are getting a lot more comfortable with the idea of using 3D. And I think that the precursor to AR is going to be really great 3D experiences, like non-game related 3D experiences. And that's also the bet we're making at Dabble. Like, we think that e-commerce should be spatial, right? We think that if you were buying a chair, you shouldn't be looking at a picture of a chair at all. You should just be experiencing the chair in front of you. And, lifting your phone up to view it in VR is painful. But what if you could just walk around on your desktop, walk around an IKEA showroom, look at chairs, and then pull them into a 3D scan of your own space, and view them and make that buying decision, and then share that 3D scan with a friend who can then, or an interior designer, who can modify and edit things on that 3D scan and actually suggest improvements. We've seen that, like I said, panning and tilting a 3D model is painful. But there are existing designs and models and really talented designers that have made this work. Like, if you look at the success of the Sims game, you won't believe it, but there are people who practice interior design on Sims. Like, there's a TikTok. There's a TikToker who will take requests of like different room designs, and she explicitly designs it in Sims. And if you see the way she does it, it's really interesting because Sims has figured out an interface that actually makes 3D design interesting and fun. And so that's where, I am sort of really looking forward to seeing how 3D on desktop and mobile evolves into applications that are outside of the world of gaming. And I think that is going to be the starting point to really interesting VR and AR, because once, interaction with 3D is a norm in some use cases, then I think AR and VR is just a better interface to interact with it. Because right now what we're trying to do is we're trying to convince people to use this completely brand new device on their face, and we're trying to convince them that interacting with 3D is better, right? Like, your eyes actually, if you think about it, when you look at something, your eyes, yes, you have depth perception, but you're really still looking at a 2D image.
Exactly.
Right? Like, you can't read in 3D. You can't watch a movie in 3D. You can experience a world in 3D, but what does that mean? Like, what are we experiencing? What worlds are we experiencing outside of AR and VR today, right? Maybe gaming. And so I think that needs to change. There has to be an incentive or a reason that AR and VR makes this digital interaction better. And I think that's like, I'm actually excited about the fact that phones have LiDAR now, because, one of the things I'm excited about is like, if I could take a picture and share it with someone versus if I could take a spatial memory and share that with someone, how could that change things? Not walking around and scanning a room, that would be ridiculous. But if I could just take a picture and that turns it into a 3D space, right? There's papers and approaches from Facebook and research papers that are out that will take any photo and turn it into a 3D photo. And I think I think that's the general thought process, is if you can make 3D content really interesting and useful outside of AR and VR, then that makes AR and VR even better. So yeah, that's where I see things evolving. Like, I don't expect AR even to be a hit. Like, if AR glasses came out tomorrow, I don't think that's going to be a hit. It's going to take a long time for that to actually materialize. And it's not like, so here's also what I think is like, AR and VR is different from, AI or NFTs. Like, AI enables new data and new applications, and can be and has broad-ranging applications across industries. Same with crypto, right? Crypto is fundamentally changing the infrastructure of businesses, and economies. But AR and VR is a new way to experience visual content, and so it's like you have to you change your expectations, I think, to something where it's like it's a new kind of monitor, right? It's not changing the infrastructure of business. Yes, it's creating a whole new platform for applications, because now, instead of just having an IP address, digital content can have a physical visual address in the metaverse. But I think we are still discovering the impact that can have. And, it's I think intuitively it seems like something that will have a big impact, but it's still, I think, an open question to figure out exactly how that will happen and when. But in general, I am very bullish on using 3D as new modes of interaction in mobile and desktop, and starting with e-commerce.
Great. Well, Neil, it was a pleasure having you on the All Things XR podcast. Thank you very much.
Thanks for having me.